A Vactrain is a proposed design for very high-speed rail transportation. It is a maglev line using evacuated or partly evacuated tubes or tunnels. The lack of air resistance could permit Vactrains to travel at very high speeds, up to 4,000 to 5,000 miles per hour, which is 5 to 6 times the speed of sound in Earth's atmosphere at sea level, using relatively little power. Vactrains might use gravity to assist their acceleration. If these trains achieve the predicted speeds, the trip between Beijing and New York would take less than 2 hours. Surpassing aircraft as the world's fastest mode of public transportation. However, without major advances in tunneling and other technology, Vactrains would be prohibitively expensive. Several articles published in China around 2010 claim that researchers at Southwest Jiao Tong University in China were developing a Vactrain to reach speeds of 1,000 km per hour. However, closer examination shows that the many papers published at SWJTU never use the term Vactrain, and instead refer to the ETT work of Oster, Zhang, and Wang. History. Russian professor Boris Weinberg offered a Vactrain concept in 1914 in the book Motion Without Friction. He also built world's first model of his proposed transport in Tomsk Polytechnic University in 1909. Later, Vactrain appears in the story, Mercenary, by Mac Reynolds, published in April of 1962, where he mentions vacuum tube transport in passing. During the 1970s, a leading advocate, Robert M. Salter of RAND, published a series of elaborate engineering articles. An interview with Robert Salter appeared in the LA Times. He discussed, in detail, the relative ease with which the U.S. government could build a tube shuttle system using technologies available at that time. Maglev being poorly developed at the time, he proposed steel wheels. The chamber's door to the tube would be opened, and enough air admitted behind to accelerate the train into the tube. Gravity would further accelerate the departing train down to cruise level. Rising from cruise level, the arriving train would decelerate by compressing the rarefied air ahead of it, which would be vented. Pumps at the stations would make up for losses due to friction or air escaping around the edges of the train itself requiring no motor. This combination of modified gravity train and atmospheric railway propulsion would consume little energy, but limit the system to subsonic speeds. Hence initial routes of tens or hundreds of miles or kilometers rather than transcontinental distances were proposed. Trains were to require no couplers, each car being directly welded, bolted, or otherwise firmly connected to the next. The route calling for no more bending than the flexibility of steel could easily handle. At the end of the line, the train would be moved sideways into the end chamber of the return tube. The railway would have both an inner evacuated tube and an outer tunnel. At cruise depth, the space between would have enough water to float the vacuum tube, softening the ride. A route through the northeast megalopolis was laid out, with 9 stations, 1 each in D.C., Maryland, Delaware, Pennsylvania, New York, Rhode Island, Massachusetts, and 2 in Connecticut. Commuter rail systems were mapped for the San Francisco and New York areas, the commuter version having longer, heavier trains, to be propelled less by air and more by gravity than the intercity version. The New York system was to have 3 lines, terminating in Babylon, Patterson, Huntington, Elizabeth, White Plains, and St. George. Salter pointed out how such a system would help reduce the environmental damage being done to the atmosphere by aviation and surface transportation. He called underground very high-speed transportation his nation's logical next step. The plans were never taken to the next stage. At the time these reports were published, national prestige was an issue as Japan had been operating its showcase bullet train for several years and maglev train research was hot technology. The American Planetron would establish transcontinental subway service in the United States and provide a commute from Los Angeles to New York City in 1 hour. The tunnel would be buried to a depth of several hundred feet in solid rock formations. Construction would make use of lasers to ensure alignment and use tungsten probes to melt through igneous rock formations. The tunnel would maintain a partial vacuum to minimize drag. A trip would average 3,000 miles per hour and subject passengers to forces up to 1.4 times that of gravity, requiring the use of gimbaled compartments. Enormous construction costs were the primary reason why Salter's proposal was never built. Starting in the late 1970s and early 80s, the Swiss metro was proposed to leverage the invention of the experimental German Transrapid maglev train, and operate in large underground tunnels reduced to the pressure altitude of 68,000 feet at which the Concorde SST was certified to fly. In the 1980s, Frank P. Davidson, a founder and chairman of the Tunnel Project, and Japanese engineer Yoshihiro Kiyotani tackled the transoceanic problems with a proposal to float a tube above the ocean floor, anchored with cables. The transit tube would remain at least 1,000 feet below the ocean surface to avoid water turbulence. On November 18, 1991, Gerard K. O'Neill filed a patent application for a Vactrain system. He called the company he wanted to form VSE International, for velocity, silence, and efficiency. However, the concept itself he called magnetic flight. The vehicles, instead of running on a pair of tracks, would be elevated using electromagnetic force by a single track within a tube, and propelled by electromagnetic forces through tunnels. He estimated the trains could reach speeds of up to 2,500 miles per hour, about 5 times faster than a jet airliner, if the air was evacuated from the tunnels. To obtain such speeds, the vehicle would accelerate for the first half of the trip, and then decelerate for the second half of the trip. The acceleration was planned to be a maximum of about 1/2 of the force of gravity. O'Neill planned to build a network of stations connected by these tunnels, but he died 2 years before his first patent on it was granted. Dr. James Powell, former co-inventor of superconducting maglev in the 1960s, has since 2001 led investigation of a concept for using a maglev Vactrain for space launch, where the StarTram proposal would have vehicles reach up to 8,900 miles per hour to 19,600 miles per hour within an acceleration tunnel. Considering boring through the ice sheet in Antarctica for lower anticipated expense than in rock